Up till now, we have talked about the forest resources, food and water resources, and mineral resources, as well as the land resources. Today, we'll be discussing the energy resources. Now, as far as energy resources are concerned, they are actually categorized into two. The first category is of the non-renewable energy resources. The second is of the renewable energy resources. Right? Now, what do we mean by the non-renewable energy resources? Non-renewable, those who cannot be renewed. So there is limited supply of these kind of resources in nature, and that is why they are known as non-renewable. We do not have endless supply, and generally these are the fossil fuels. I have given you examples of the fossil fuels here also. Now, why are they called fossil fuels? Fossil fuels because they are formed from the fossilized deposits of plants actually. What do we mean by fossilized deposit? Those prehistoric plants and animals that existed in earlier times, their remains got buried under the earth's surface, and because of this, their transformation took place over a million of years, right? And this transformation was actually assisted by very high pressure and very high temperature, and this led to these remains getting transformed into fossil fuels, and that is why we know them as fossil fuels, because the origin is the fossilized plants. Fossilized means which have been buried deep under earth and which have been transformed under the in the presence of very high temperature and very high pressure, right? So the examples of these kind of non-renewable energy resources are the mineral-based hydrocarbon fuel, which includes coal, crude oil, and gas. Why are they also known as hydrocarbon fuel? Because if you look at their formula, you would find that there is presence of both hydrogen as well as carbon, right? Now remember that the non-renewable energy sources are the ones which we have been using traditionally. So their use dates back to earlier periods than when you compare it with renewable energy sources. So we have been using these renewable energy sources since a very long time, and that is why they are also known as traditional, because we have been using it since very long. We have been using coal, firewood in our houses, so that is why they are known as traditional, right? So they are also known as traditional energy resources. Apart from that, they may also be known as since they've been used since a long time, they've been used since very long ago, so that is why they are also known as the conventional sources of energy. So they can be said to be traditional sources of energy, also they can be said to be conventional source of energy, right? Now renewable energy sources again would not be, they have been under use by the mankind only in the last few years or decades. So that is why they are known as the non-traditional and the non-conventional energy sources. Now if you look at the renewable energy sources, you would find that their supply is unlimited in nature, and that is why we are saying that they are constantly getting replaced. So even if we consume some of them, they get constantly replaced. So since their supply is endless in nature, they are known as renewable energy sources. So we don't need to worry about these energy sources getting consumed. So that is why they are known as renewable energy sources. And I've told you that the other term for renewable energy sources is the non-conventional energy sources or the non-traditional energy sources, right? Now what are these types of renewable energy sources? And please understand, they are generally less polluting than the non-renewable energy sources. So if you talk about the examples that we have of the renewable energy sources, including the hydroelectric power, the solar energy, the sun's energy, the energy of the fast moving air or wind, the energy of the biomass, we'll be discussing each one of them separately, the geothermal energy, the energy that basically remains inside the earth. That is why the word geo here. And the heat energy that is trapped inside the earth, when we start harnessing it, it is known as the geothermal energy. And the energy of the tides that we have in our coastal areas is known as the tidal energy, right? So there are different types of renewable energy sources. We'll be discussing them one by one. Now let us start with the discussion on the non-renewable energy sources. Fine. So the first one, which is the first example for a non-renewable energy source, is coal. And the energy that we produce from coal is known as thermal energy, right? However, please understand that coal is the single largest contributor of greenhouse gases, and that is why the use of coal is responsible for global warming. Greenhouse gases are emitted when you use coal. These heat up the global temperature and lead to global warming. So coal is a very, very polluting source of energy. And how do we harness the coal energy, the energy from the coal? What we do is basically we heat up coal, we burn coal basically, and the energy that is produced, the heat energy that is produced, is used to heat up water. Water gets converted to steam, and this steam is made use of to turn the wheels of the turbine. And the turbine does what? Turbine would convert this mechanical motion, the movement of the wheels of the turbine would then get converted to electricity, electric energy. Is this okay? So this is how the coal power plants work, and the energy that we harness by using coal is known as the thermal energy. Now you understand why it is called thermal energy. Thermal means heat. So basically we are using coal, we are burning it so that we can produce some heat. That heat is getting used to vaporize water, which then ultimately runs the turbine, and then ultimately the turbine produces the electrical energy. Is this okay? Now again, what are the problems as far as the combustion of coal is concerned, or production of thermal energy is concerned? If you look at the India's energy mix, you would find that a majority of our energy requirements are met by coal. So we have a lot of thermal power plants, and they meet a majority, that is more than half of our energy requirements, right? Now, and the one reason for this is that we have a lot of coal deposits here in India. So that is again one reason for this particular fact. Now, as far as the coal is concerned, whenever it is burnt, it leads to emission of suspended particulate matter. So that matter, which is very, very small in size, it is measured in microns. These kind of matters are basically measured in microns, and this could be 5 micron, 10 micron. So these kind of particles are emitted of this particular size, and then 1 micron is 10 raised to the power minus 6 meters. So very, very small particles are emitted, and these particles, they remain suspended because they are very, very small. So what will happen, since they would be very small, they would be very light also, and they would not fall down to the earth's surface quickly. So they would remain suspended in the atmosphere, and that is why they are known as suspended particulate matter. Now what happens is, when somebody breathes, the particulate matter along with the air will enter the lungs, and then it would cause problems in the lungs. So the various respiratory issues, maybe like asthma, maybe other kind of respiratory problems, respiratory tract problems, are caused by the suspended particulate matter. Is this okay? Now let's talk about the fly ash waste, which actually gets produced whenever you are burning the coal. So for that we have come up with a solution to dispose the fly ash. Now fly ash is something that gets produced when you are burning the coal, and the solution is that you dump the fly ash in the very, very large dump pits, and this is how you actually dispose it of. So basically fly ash is disposed of how? Very large pits are created, which are known as dump pits, and there you actually dump the fly ash. Fine. So this is how we dispose of the fly ash that is produced during the production of thermal energy. Again, the combustion of coal also leads to production of sulfur and nitrogen oxides, SO2 and N2O, which when combined with vapor, SO2 combines with vapor, sulfur dioxide is SO2, sulfur dioxide when combines with vapor, H2O, becomes sulfuric acid. Likewise, nitrogen oxide, N2O, when combines with vapor, again becomes another kind of an acid, right? So the products of the combustion of coal are sulfur dioxide and nitrogen oxide. When they further get coupled with water, they lead to formation of acids, and this acid which is formed in the atmosphere, when this falls along with the rain to the ground, it is known as the acid rain. And acid rain may cause so many issues, damages to buildings, in fact to our architectural monuments. For example, Taj Mahal has suffered damage because of acid rain in the area in the vicinity of Agra, because as you know that Agra is well known for leather industry. So there used to be a lot of pollution in the vicinity of Taj Mahal and a lot of emission of sulfur and nitrogen oxides, which used to ultimately cause acid rain. So there was a significant damage to the Taj Mahal in Agra, and then the court ordered the industries which were located in the vicinity of Taj Mahal to be shifted away from Taj Mahal. So then the frequency of this acid rain has declined after that particular ruling by the court. So the acid rain can damage the buildings, it can pollute water. It not only this, it is also going to affect the human health, and plus it also destroys the vegetation. So acid rains, it may cause irritation in your eyes, it may cause skin issues, skin problems. So the acid rain is also damaging to the human health also, and as well as the flora, the floral population of a particular place, the vegetation in a particular place. So this is why the governments are planning to switch from the thermal energy to more to less polluting sources of energy, like the renewable energy sources. Now let us move over to oil and gas. Now oil and gas, why I am mentioning both oil and gas in the same slide and in the same breath? The reason is that generally wherever oil is found, you also find gas. That is why I am mentioning them at the same place, though they are different separate fuels, for example. Now what are the problems associated with production of oil and gas? There could be, now this is a photograph just to make you understand what I am trying to show you here. This is a photograph of a oil well in Bombay High. Bombay High is an offshore. Offshore means it is a little far away from the shore, and it is in the middle of the sea basically. So it is at a distance from the coastal areas of Mumbai. This is called an offshore, away from the shore oil rig. And from there, and as I told you that this basically is Bombay High, one of the prominent oil producing areas for India. And though this particular oil well is in the middle of the sea, however there can be oil wells which can be inland also. For example, in Assam we have some oil wells, in Digboi, and there are other such places. Apart from that, in Gujarat also we have got some oil wells, right? For example, Ankleshwar in Gujarat, Ankleshwar, right? So what I am trying to show you here is that this is how you actually extract oil from the earth's surface. Now what are the production hazards? One production hazard is the leakage. Leakage while you are trying to extract oil, where you are pulling oil out from the reserves, extracting oil from the reserves, there could be leakages. There could be accidental fires, because oil, you know, is a combustible material. So if it is exposed to fire, if it is exposed to fire, what will happen is that there might be fire accidents. It may catch fire. Then at times what happens, oil spills from offshore oil wells. This I told you is an offshore oil well. Offshore, I have just now explained it to you. So this is an offshore oil well. Many times oil spills out of these kind of wells. So oil wells, generally which are offshore, they run the risk of minor amounts of oil spillages once in a while, and this will cause damage to the aquatic life, to the marine life, because what will happen, the oil spill, the oil layer would get deposited at the top of the water. The water and oil, they are immiscible, they cannot mix with each other. So what will happen, the oil layer will get deposited at the water surface, and then what will happen, it will cut off the oxygen supply to the marine organisms in the water, and they would not be able to survive. So it is very much damaging to the marine aquatic life. Then again, oil spill could also happen because of shipwrecks. Why do shipwrecks happen? See, I have told you, and I think we have discussed it earlier also. What happens is, for example, you know that India imports 90% of its crude oil requirement. Naturally, these crude oil imports that we are getting from America and Gulf countries, they must be arriving in India. This crude oil arrives in India in tankers. What if some of the tankers meet an accident while coming to India, while still in the middle of their journey in the sea? Then the oil would again spill on the sea floor, and as I said just now, it will cause damage to the marine ecosystem and aquatic life. Again, what are the problems associated with the consumption of oil and gas? Refining produces solid waste. When you actually refine, what do we do in refining? Basically, generally what we get is crude oil. India actually imports crude oil, and then we go for fractional distillation to obtain different components from this crude oil. Crude is kacha tel. So from that, what we do is we basically go for the fractional distillation, and using fractional distillation, what will happen, we will get different components. So for example, one component would be petrol, the other component is, let's say, diesel. So there are other components also. This is how we obtain various components, and this process is known as refining. However, refining can also produce some solid wastes. For example, we have talked about these solid waste here. Have a look at the examples. Salts and grease are also produced during refining. They are harmful for the environment. So this is one issue with the exploitation of oil and gas. Now then, vehicular pollution is another issue. When you are using oil and gas for transportation purpose, right? So when they are just a moment, when they are being used for transportation purpose, right, what will happen, they will see, oil is not getting used directly for transportation purpose. It is first getting refined into petrol and diesel. So these are the refinery products, right? India has got a vast network of refineries, both in public sector and private sector. I hope you know. For example, in public sector we have got Indian Oil Corporation. In the private sector we have got Reliance also, and there are other companies also. So basically what we do here is, once we have refined the crude oil and we have obtained petrol and diesel, they are used for transportation purpose as fuel. Now what will happen when they are being used as fuel, and when the vehicle is running on petrol and diesel as fuel, there would be emissions of pollutants. So pollutants like carbon dioxide, sulfur dioxide, nitrous oxide and carbon monoxide, and apart from that, particulate matters get produced. They cause acid rain. We have discussed the mechanism just now, and they also cause respiratory tract diseases. I've talked about that as well. Particulate matter is specifically would cause respiratory tract diseases. Respiratory is how we actually breathe. So we are basically talking about the organs in the body that help us breathe, so which includes the windpipe, the nose, the nostrils, windpipe, and then the lungs. So the respiratory tract diseases are also caused by emission of these pollutants which get emitted when we are using petrol and diesel, right? Now what about leaded petrol? See, leaded petrol is actually used when we basically add lead to the petrol, and this is done to control the pollution level. However, this also can cause problems. The leaded petrol, lead in itself is a very damaging poisonous substance for the human body. So what happens is, basically, please understand, when we start using leaded petrol, so that we can control the emission of pollutants, what will happen? It may lead to neurological damage. It can cause problems with the nerves and the nervous system, and it also, again, since it is causing neurological damage, it is also reducing the attention span. So it is difficult for children who have suffered from lead poisoning, lead, sisa poisoning. It is difficult for them to attend to a particular stimuli, so they suffer from attention deficits. So it is difficult for people who have been exposed to lead. They find it difficult to attend to a particular stimuli for a long period of time. So reduction in attention span is a big problem. On the other hand, if you start using the unleaded petrol, what will happen? Unleaded petrol contains carcinogens, and remember, from now onwards, what do we mean by carcinogens? Cancer causing material is known as carcinogens. Those chemicals which cause cancer, they are known as carcinogens, right? So unleaded petrol has carcinogens, which means, and these are some of the examples of carcinogens which unleaded petrol has: butadiene and benzene. Now please understand that the exposure to these chemicals may cause cancer, has been found to be correlated with the cancer disease. Okay. Now, one more issue with the use of oil and gas and their derivatives, that is the refinery products in transportation, is that they lead to production of smog. Smog is basically smoke plus fog, right? And smoke from the vehicular emission, when mixes with the fog, and generally happens during the colder parts of the year, this actually leads to production of smog, which reduces visibility, causes irritation, again causes problem for those who are already suffering from respiratory tract diseases. Asthma attacks may increase in people who also already have this kind of a problem. Visibility becomes a problem. Then the inhaling of smog may lead to various other diseases of lungs. So these are the problems associated with smog. Again, one more issue with the oil and gas is that they are unequally distributed. For example, in India, if you look at India, you would find that India does not have sufficient reserves of oil and gas. On the other hand, if you look at the Gulf region, the Khadi Desh, as we call them in Hindi, or the Middle East countries, including Iran or Iraq and the countries in that particular area, Kuwait, Qatar, all these countries, Saudi Arabia, these countries are richly endowed with crude oil and gas deposits. So there is an unequal distribution of crude oil and gas. On the other hand, there is a high level of dependence on these sources of energy, be it for transportation requirement, be it for running our industries. We depend a lot on oil and gas, and naturally now this unequal distribution of oil and gas has been the reason for so many political conflicts, so many political tensions, so many instances of instability, specifically in the Gulf countries, and wars. For example, in 1990s there was a war which took place between Iraq and Kuwait also, wherein Iraq wanted to control the oil production centers in Kuwait. Likewise, there have been so many wars fought over oil. So this is one more reason that oil and gas, apart from its impact on the ecosystem, on the environment, it is strategically also responsible for causing so many problems in different parts of the world, so many conflicts in different parts of the world, right? Now this concludes our discussion on the non-renewable sources of energy. After this, I think we will have to move over to the renewable sources of energy. So I'll be discussing a few of them today. So one renewable source of energy that we have already discussed, and you can find out from here, is the hydroelectricity or the hydroelectric generation, right? You can see a dam here. The reservoir is on the other side. You can see the reservoir is somewhere here in between these two hills. There's a reservoir here which is not visible from here, right? And this is where the water is being stored, and then water will be made to move through these gates, and when the water moves through these gates, the potential energy, because of storage, will get converted to kinetic energy. Water will move at a very high speed, and this would turn the turbines here, and this would generate electricity. So this is how we are able to generate hydroelectricity. So we have seen this here, water flowing down natural gradient. Natural gradient means natural slope. Gradient means a difference, and here what we mean by natural gradient is a difference in height. So water would flow down from a higher plane to a lower plane. So from a place which is at a high altitude to a place which is at low altitude, and this will actually produce energy, and this energy will get converted into electrical energy when the turbines and their blades are made to run with the water flow. So this is how hydroelectricity is produced. Now what are the advantages? I suppose, and I hope that you remember already our discussion has taken place as far as hydroelectricity is concerned. So I hope that you would have that discussion in your mind fresh. So I'm just going to browse through this discussion here today. So advantages are, again, renewable source of energy. Then there is a long life of hydropower plants. The operational costs are low, the maintenance costs are low. Once you have set up the plant, once the plant has been constructed, once the dam, reservoir, everything has been constructed, after that you don't have to worry too much about the maintenance cost, because the maintenance cost and the operational cost is going to be very, very less. Right. And again, there is an absence of inflationary pressures. What do we mean by inflationary pressures? Inflation, I hope you know, Mengai. Now I'll tell you what we mean by inflationary pressure. For example, just now we have been discussing crude oil and gas. Now you know that the prices of the crude oil and gas keep changing whenever the demand decreases across the globe, which happened in the COVID-19 crisis. What happened? The demand decreases, the supply is still the same, so naturally there would be a decline in price. On the other hand, when the world economy is doing well, which is generally the case, what will happen? There would be a lot of demand for oil, and there would be an increase in the market prices. So the crude oil and gases generally tend to become costlier. If you look at a longer term picture, you would find that generally tend to become costlier. And naturally, if you are using crude oil and gas and coal, so naturally, since they've become costlier over years, it would be costlier for you to harness their energy, and naturally it would be costlier for you to use that energy. On the other hand, that is not the case with hydroelectricity. The water availability remains the same. There is no change in price of water as such, and again, since the operation and the maintenance costs for the dam or for the hydroelectric projects are low, so generally the cost of hydroelectricity does not increase very rapidly if you compare it with what happens in the case of energy obtained from coal and oil and gas. Is this okay? So this is one more advantage of the hydroelectricity or the hydroelectric projects. Now let us have a look at the drawbacks. What are the drawbacks? First thing, and I think we have discussed most of these, so I'm not going to get into details. So displacement and rehabilitation of human population. We have taken example of how when the Sardar Sarovar Dam was getting built, so many people had to be displaced. They had to be uprooted from their ancestral land just because the dam was being constructed there, and then they had to be rehabilitated in a separate place in a new area. So this displacement and the rehabilitation of human population, it causes various kind of frictions in the society. There might be opposition to the plans to construct a hydroelectric project, and the government also has to spend on compensating the people who are being asked to move out of their ancestral land, to leave their ancestral land, and who are being displaced because of the construction of these kind of projects. So this is one major drawback of the hydroelectricity projects. Then many a times silting of reservoirs would also happen. Now what happens in silting of reservoir? Please understand. This is, let's say this from here, somewhere here, you would find that the river is flowing in this direction, and the river, since it is flowing from a higher plane, from maybe some area in the hills, it is flowing downwards towards the plain. So what will happen, since it is flowing from a high area to a relatively lower plane, what will happen? It will have a lot of force. It will move very quickly, and when it will move quickly, it will also carry along silts, small particles including clay, sand, small rock, and small stones. It will keep carrying them. However, if the river is stopped here, because the reservoir is here, so you see the other side, it's not visible from here, the other side there is the reservoir, so naturally the water has to be stopped here. What will happen then? So all this silt which was being carried away by river, that would also get deposited here. The sand, the clay, the small rocks and pebbles, they would get deposited here, and over a period of time, if it continues, what will happen? This reservoir would get silted, and then you will have to spend money in desilting the reservoir. So you will have to do what? You will have to make use of machines, and you will have to take out the silt. So this is what silting is, and naturally it is going to cost you a lot of money, and that is one more drawback of the hydroelectric projects. Then let us talk about the conflict over allocation. Now the water is here. The water has been stored, specifically the water stored in the raining season, so that it can be stored and made use of in the dry season. But then how do you allocate the water in the dry season? What proportion would go to the households, to the families for their domestic requirements, bathing and cleaning utensils and cleaning the clothes, washing the clothes, and for these kind of purposes? And what would be the proportion that should meet the irrigation requirements of agriculture in the near vicinity? What should be the proportion allocated to the industrial firms? So now at times there is a conflict over this allocation of waters to these three different groups: the households, the farming community, the agriculture, and the industries. Again, you know, and we have discussed this also, that hydroelectricity has a very damaging impact on the riverine ecosystems, the ecosystems of the river, the aquatic life, which includes fishes, which includes vegetables which grow near the riverbeds, on the riverbeds, or on the banks of the river. So they would also get impacted. And again, we have talked about how the reservoir, which contains a lot of water, when the water is getting stored, when the water is being stored, this will exert immense pressure on the land beneath. And naturally this pressure at times can cause earthquakes in the surroundings of these kind of hydroelectric projects. So this is one more concern as far as hydroelectricity is concerned, right? What are the solutions then? The solutions are, first, don't go for very big hydroelectric projects like the one in Tehri or like the Sardar Sarovar Dam on the river Narmada, in the areas near the Gujarat and Madhya Pradesh border. So don't go for these kind of big projects. Go for small dams. So wherever there is a steep gradient, there is a steep slope, specifically in the hill areas, there might be so many steep slopes, you can construct a dam there. And this dam need not be a very big project. It needs to be a very small project with very small capacity to produce power. On one hand, for example, I'm giving an example of what is happening in China. They've got 60,000 such dams, small dams. So naturally these dams, they are very small, reservoir and induced seismicity chances are low, less impact on the riverine ecosystem, then less silting of the reservoir, so desilting is not required that regularly, and less displacement also. So in that sense they are far more eco-friendly and also don't have a very adverse impact on the surroundings and on the human population in the vicinity. So that is why China has actually constructed almost 60,000 such dams, right? And however, they are producing just 13,250 megawatt of electricity. If you do a calculation, you will find out that basically every 5 dams are producing 1 megawatt. So in a way, one dam is producing just 200 kilowatts of energy. While if you talk about the big dams, at times they are producing 300 megawatts, 400, 600, 800 megawatt. On the other hand, small dams produce only 200 kilowatts, 0.2 megawatts. So this is the kind of energy that they are producing, but the advantage is, we have already discussed, these four issues would not be there. And that is why Sweden, USA, Italy and France have also gone for these small dams rather than building very big dams. So, and this is one opposition against the Pancheshwar dam that is being designed and that is being constructed here in the areas surrounding Pithoragarh and the Champawat districts. So that is an opposition to the dam there. It may cause seismicity, earthquakes may be caused. Our areas are already earthquake prone, so again there would be impact on riverine ecosystem and the silting of reservoirs, and there would be a displacement and rehabilitation also would be required. Some 3 to 4 villages, they have already, the process of shifting the inhabitants of these villages is about to start very soon. So these kind of reasons are there because of which this Pancheshwar dam is also being opposed, right? Now we have to discuss the solar thermal energy. So let's have a brief discussion on solar thermal energy. What do we mean by solar thermal energy? The heat of the sun, and that is why the word thermal. Thermal means the heat. So the heat of the sun is being used here. So we can harness the solar energy in two fashions, in two manners. One is we can harness its heat energy, and the other one is we can use the sunlight to produce electric current. So here we are going to talk about how solar energy is being harnessed. The heat of the solar energy is being harnessed, right? How do we harness the solar heat? That is what we are going to discuss here. So this is an example of how we harness the solar heat. Solar cookers. More than 2 lakh Indian families have been using solar cookers. The sun rays are reflected and they actually are focused. So the sun rays, they get deflected like this. So this is the sun ray, and then it is getting deflected like this, and it actually is focused on this particular point. And this point here in this particular container, there would be the food which needs cooking or which needs heating, and this will actually, since all the sun rays are being focused on this particular point, and then this particular compartment has been also covered by a glass sheet, this will heat up the temperature inside, and this would lead to cooking of food. So this is how the solar thermal energy works, solar cooker works. Then we have got solar water heating. What will happen? The sun's energy would lead to water absorbing the heat and then converting to vapor rising somewhere here, and then from here it can be made use of for various domestic purposes. So this is what solar water heater does, and this is how it operates. So the cold water is coming from here, and then since it gets heated again from here, it will move to this portion after getting converted into vapor, right? Then solar desalination systems, they are made use of to convert saline water, brackish water, convert water which is found near the coast, the saline water which has salt mixed in it, so that water is converted into distilled pure water using solar desalination system. So there is no requirement of energy. The energy is obtained from the sun. Then the mirror energy, wherein the mirrors are used basically to focus the sun's energy to produce steam from water, and the steam is made use of to run the turbines and thus produces electrical energy in this particular case, right? So in this particular case, this is not the particular case. What is happening, we are able to convert the sun's energy into electric energy, but please understand, this is also example of solar thermal energy, because how we are able to do that? We are actually using the sun's heat to boil water, which then gets converted into steam, and now this is steam is basically running the turbine. So that is why this has been included here in the solar thermal energy, the mirror energies also, right? Now let us discuss some more example. How can we use solar energy in our houses, specifically in cold areas like our district, which is generally very cold, and we've got colder areas also here in this district. Many parts of the Uttarakhand hills, they are very cold. So how can we harness the solar energy here? See, solar housing can be there. In solar houses, what will happen? South facing glass windows will be there. south facing houses, they receive the maximum amount of sunlight because the sun moves from west to, the sun actually moves not from west, the sun actually moves from east to west, and the houses which are facing south, they are going to receive the highest amount of sunlight. So that is why these houses which are harnessing the solar energy, they are made to face the south direction, and there are glass windows so that the heat could come in and get trapped inside. Then sun spaces are created. In these sun spaces near the glass window, what will happen, there would be heat absorbing tiles and bricks. So these heat absorbing tiles and bricks would be there, so they would do what, they would absorb the heat during the daytime, right? And since they would absorb heat during the daytime, what will happen, it will lead to the temperature falling down because the heat is getting absorbed by these bricks and tiles. On the other hand, when it would be cooler outside and there would be no more sun available during the evenings and the night, these tiles and bricks would start emitting, releasing heat. So it would raise the temperature inside. So these tiles and bricks, they are actually moderating the temperature in the afternoon, and during the morning and the afternoons they are absorbing the heat, so the temperature does not rise too much. On the other hand, in the evenings and the nights, they release heat so that the temperature does not fall too much. So this kind of moderation effect is there because of these kind of sun spaces with heat absorbing tiles and bricks. Now we have got energy efficient architecture also. I thought this is the right place to discuss these energy efficient architectures, wherein we are basically using not only the sun but the other natural forces also, including the water and wind, for temperature control. And you might find this kind of architecture in our historical monuments, because they used to be designed in a very scientific manner. So if you go to any historical monument, be it Taj Mahal, be it places like the Lal Killa, there you would find this kind of energy efficient architecture being in use. So just we will browse through the main elements which are there in the main aspects that are taken care of in energy efficient architecture. So thick walls of stone and mud as insulators, they don't let the heat move out and they don't let the heat move in, which means they would keep the room cooler, because they are not allowing, insulator is what, it does not allow the heat to pass through, so they would not allow the heat to pass from the the external walls to the inside of the room. So this is one way in which you can reduce the temperatures during the summer months. Then small doors and windows so that the direct sunlight is kept out, the heat and the sunlight is kept out and the room is cooler. Then we've got high roofs and ventilators from which the air can escape, they are called ventilators, right? So high roofs, what will happen, hot air can rise up, you know that when the air heats up it becomes lighter and then it rises up, right? So the hot air can rise up, and then why is it rising up? If you have got roofs which are not that high, right, what will happen, even if the air rises up, it won't simply have the space to move about. On the other hand, if there are high roofs, then the hot air will have empty space so that it can move high, it can move up because the roofs are relatively higher. And then what will happen, because of the ventilators, the cooler air from outside will come in and the hotter air, it would push the hotter air outside, so there would be cross ventilation. So from one particular window the cooler air is coming and it is driving out the hotter air. So what is basically happening, the hot air from the room surface is rising up and there it is getting pushed out by the cooler air from the other window. So the windows will be placed opposite to each other. So from one window there would be cooler air coming in and then it would push the hotter air outside. So this is how the room would remain cool. Cross ventilation, just like I said, the windows would be exactly opposite each other, so that the wind or the air can drive the hot air in and out of the room. So the wind would drive the cool air inside the room, and then the cool air inside the room that is coming inside the room will drive out the hot air from the room and it would drive it outside the room, right? So this happens when there is a cross ventilation kind of a arrangement made. Then we've got large overhangs over windows so that the glasses don't heat up. And if the glasses heat up, then they will create some kind of a greenhouse effect. We don't want that. So what we are doing is we are constructing large overhangs over the windows so that the glasses don't heat up and then don't heat up the room also. Double walls to prevent heating, and shady trees are also planted in the courtyard so that the temperatures may be kept in control and so that there is a movement of air. Right, so all these things are taken care of to construct energy efficient architecture. And I've told you, if you visit any historical monument, you might be able to witness and come across the actual use of these engineering principles there. So be it any monument, be it Taj Mahal or Lal Killa, and so many monuments are there. If you go there, you'll find that all these principles are being taken care of there. And the time at which these monuments were built, at that point of time, the people didn't used to have any fans or ACs, but they were still able to survive in the hottest of the months, and they still were able to carry out their daily activities in the hottest of months just because the architecture actually adhered to these principles. Right, now let us talk a little bit about the solar photovoltaic energy. So this is the other type that I was mentioning. The one was wherein we are trapping the heat of the sun. This one is wherein we are making use of the sun's energy, the sun rays, to produce electric energy. So electricity from sunlight using, so we've got silicon panels here, photovoltaic cells, and that is why this kind of energy is known as photovoltaic energy. So we've got photovoltaic cells, and what do? You can actually read the mechanism in detail. In fact, you might have read about this in detail while you discussed semiconductors in your higher secondary classes. So there you might have discussed how the photovoltaic cells actually work. So electricity from sunlight, when it is incident on the silicon panel, that sunlight gets converted into electric energy. Right, now advantage is that it is a very clean and safe source and easy to install, and the maintenance is also not going to be very costly. So low operational cost, low installation cost also. Right, so this is these are the advantages, and that is why solar photovoltaic cells are used in satellites. And this is how satellites keep working for years at end, because they obtain their energy from the sun and they convert it into electrical energy, which then runs the various machines in the satellite and various operations in the satellites. So solar photovoltaic energy is basically used in satellites. In highway lighting, you must have seen in highways there are solar panels, and nowadays even in our villages you would find these kind of solar panels working. Small electrical appliances are there which work on the same principle and which actually harness the sun's energy and convert it into electrical energy. You can talk about the solar lights that we have, solar emergency lights. So you have to get them charged during the daytime when the sun is out, and then they would work during the evenings when it is dark. And again, watches and calculators also at times use solar photovoltaic energy. Right, now this is an example of how we are making use of the solar energy to convert it into electricity. So this is the solar panel, this is the silicon panel that we are talking about. The sun's rays are incident here, and the energy that is getting produced is not only fulfilling the requirements of this particular house, but also it is being fed back. Now have a look, this is being fed back into the grid. Now this is the grid. So the extra energy that is getting produced is being fed back into the grid, into the electricity grid. Right, and this is what is known as rooftop solar energy generation. Why? Because the panels have been installed at the top part of the house, on the roofs, and that is why this is known as rooftop solar energy generation. And maybe 15 years, 20 years down the line, 30 years down the line, you might see households not only producing their own electricity, not only deriving all their energy needs, fulfilling all their energy needs from the solar energy by converting it into electric energy, also you might find them earning money by feeding the excessive solar energy back into the grid, and these kind of projects have started in different parts of the country. Now, what do we mean by this? See, the electricity grid, there is an arrow pointing downwards and there is an arrow pointing upwards. See, this energy can only be harnessed when the sun is out. So what will happen if, say for example, 3 to 4 days there has been no sun, it has been raining for 3 to 4 days, what will happen in those times? Or when it is too dark, or maybe during the winter months, what will happen? This house would be actually using the energy from the grid, using the electricity from the grid, and that is why this, have a look at this particular arrow. So we are getting energy from the electric grid. On the other hand, whenever we have abundant of solar electricity, energy produced by solar energy, then what we'll do, we'll use some portion of that for our own purpose, our own consumption. We'll consume it in our house, the remaining would be fed back to the grid. So this is what is being thought of as a very, very good model, because now the households can also earn something. So they can earn by producing the solar energy, which would then be fed back into the grid. This would reduce the pressure on the grid also. Now you don't have to rely. Ultimately this grid power, I told you, is coming basically 60%, around 60% of it is being generated from coal. I told you that mostly we are using coal. A majority of our energy requirements are fulfilled through the coal based thermal power plants. So in that sense, the pressure on the thermal power plants would also be reduced, and there would be less consumption of coal there, which would basically do what? Basically reduce the damage to the environment. So this is a model that is being thought of, and maybe in the next 10-15 years you might actually start witnessing these kind of houses and these kind of arrangements in your localities also. Now, what are the drawbacks? Of course, this is a renewable source of energy. There is no lack of sun. There is no risk of sun running out of its fuel, at least in our lifetime. So it is a renewable source of energy, that is an advantage, but then there are some issues. What are the issues? What are the drawbacks? First thing is the photovoltaic cells that are used in these panels. Right, these panels are using photovoltaic cells. They may contain small quantity of cadmium, which is basically toxic. Cadmium is another element which might be a little toxic, and if these panels are burned, then the cadmium will get released. Until unless you are burning it, there is no chance of cadmium getting released into the environment. But the moment they are burned, then there would be a release of cadmium, which again can impact not only the human lives and the animals, it can also impact the environment. Again, another issue is with the silicon mining. I hope you remember that silicon is the second most abundant element present in earth. We have talked about this on the earth crust, second most abundant. Now there are problems associated with mining, and we have discussed them when we discussed the mineral resources. So you refer to those notes and you would find out that there are issues associated with mining, and those issues are also associated with mining of silicon, and that is why mining may cause damage to the environment. And then, okay, there is a spelling mistake here, so please note that this is not better, this is better, BETTER. So we need to have storage capacities if we want to rely on solar photovoltaic energy. Why? Now I tell you why. See, I told you, what would you do during the nights? There is no sun available during the night. So how are you going to fulfill your energy requirements at night, or maybe during the rainy season? So you would require some kind of a battery, some kind of a storage would be required, so that the sun energy, the solar energy which is harnessed during the daytime, it can be stored for use during those times when the sun is not out there, when it is not sunny at all, during the rainy seasons or during the night. So you also require some kind of storage infrastructure. It could be the batteries, but then again these batteries is going to be costly, and this is one problem associated with the solar photovoltaic energy. Right? With this we are basically concluding this session here, and there would be one more session in this particular unit wherein we will be talking about the other renewable resources, which includes the biomass energy, the wind energy, the tidal energy, geothermal energy, the wave energies. So we will be discussing all these in the next session, and keep reading. Thank you.